Welcome back to another set of lovely Max MSP exercises. In this one, we're going to look at randomizing stuff. First, we're going to look into ways of randomizing, and then we're going to look into stuff in terms of different things that we can randomize. So, the basic thing to begin with is the random object. It allows me to specify a range. So each time it receives a trigger, it will send out a number in that range. Now, the crucial thing is that the numbers coming out have equal likelihood of happening, of occurring. So this is what we call uniform distribution. So if you ask me, is there a way to verify that? There is, and we verify that with the use of histogram. So we have the object histo, and we have an object itable that can connect to this one. And it can actually display the content of the histogram quite neatly. So the histogram is actually a way of representing all the things that have happened. So if I have a suitable range here, let's see, it's 128, let's do 100, both vertical and horizontal, then I should be able to display up to 100 occurrences of what's coming in here. So if I just keep sending the numbers there, you probably see how they start to appear at the bottom. So those are all the numbers that are happening, and then some of them happened multiple times already. They're slowly rising. Obviously I can make this go much faster. Let's do 200 numbers per second. I cannot click that fast and see them go up. So what you see is that, you know, not all numbers occur the same amount of times, but overall, supposedly, this is what we call a uniform distribution. There's an equal likelihood, so after a while, they all definitely occurred at least once, some more times, some less times. Actually, this one up to, what is that, a third of the vertical axis, maybe up to 30 times more frequently than this one. So it is in no way truly flat, the distribution, but that's what it is. So that's what we call uniform distribution. And this is a neat way of verifying the distribution, which we can use later as well. It responds to a clear message, if I remember right. So I can remove that for now. Did it not? Help file is handy. Clear. Looks good. It just didn't update the graph. That's fine. It will do when we send it the next value. Let's send it to 0. No. No. I won't deal with this now, thank you. Cool, so uniform distribution. I got a bit distracted there, which I find quite important in doing these online videos. I find them a bit dry without distraction, so I'm tempted to say a joke, do something funny. Maybe I will. So anyhow, we're talking, back to the point, we are talking about random values, and we are talking about the ways we can control streams of random values. Now the first important thing there is the range. Now how do we specify the range? Well, the most straightforward thing is min and max. This is something that we readily understand in terms of there is a random value within a range. Typically when you talk about a range, you are likely to specify two values. What is the minimum occurring value, the maximum occurring value. So that's one thing, but then there is another thing which is quite useful, which is center value and range, or I'll call it deviation. We like cultural deviation. There's a joke. So you will find that in certain situations one will be more useful, in certain situations the other. So the first thing I'll do is I'll make both of these. So how do we do that? Well, random itself won't let you specify the minimum value, it specifies the maximum value. So what we'll have to do is a bit of math. So well, let's keep this metronome for now, potentially. Oh god. And get the math done. So what we need to do is figure out how to transpose this. So maybe the simplest thing to do is take just arbitrary numbers. Let's say I want a range between 20 and 40. 20 is minimum, 40 is maximum. Well, in that case, what I need is 20 random values. And if I get 20 random values, they will run between 0 and 20. Let's make this potentially visible. So they run between 0 and 20. And then what I will have to do is offset or add 20 to that, and then I get random values between 20 and 40. Okay, so that's one example. Now what I want to do then is make this an option. I want user parameters to allow any arbitrary range, so minimum and maximum. So what you see here already is that 0 to 20 in that scenario, 0 is the minimum value, and if I wanted 20 to 40, so if I want to change the minimum value, I'm adding the actual minimum value. So the minimum value is the offset. And if you think about it, it also works for negative values. So if I want the negative value to be the minimum value, because 0 is the minimum value coming through, I subtract 74. In that case, the smallest value coming out of here will be minus 74. So the minimum is actually the offset, so that's easy. Now the maximum is not straight off the range here, because what you get is that the maximum will be the offset plus this range. Okay, so if we go back to our simple example, try and keep things simple, we have 0 to 20. Okay, and if I want 20 to 40, you see what happened there is that I would have specified this to be 40. So the maximum needs to be 40, but the range of random values is not 40. It is 20, because the range of values that I need is the difference between minimum and maximum. And having said that, that's what I'm after, the difference. Okay, so what I do is from maximum I subtract minimum, and then I get a value that should be the range. Now in max MSP, the right inlet won't trigger the calculation, so I will just make sure that when I change the minimum value, I do the calculation as well. So let's try that. Let's say 22 to 27. Okay, so that's the math here. 27 minus 22 is 5. And indeed, if I want my random generator to go between these two values, let's keep those two, 27. There it is, 22. It always picks the 26, you see, because the random itself always excludes the value specified, because it's not the maximum value, it's the range. So if I want to be really precise and have both included, because 22 is included, 27 not, a quick hack would be to add 1. Okay, so then we can test that. That's the minimum, that's the maximum. From maximum we subtract the minimum. And well, let's take 13 to 14. Okay, so now both are included, and that works well. I wonder what happens with the negative values. -12 till -7. It's looking good. And then the last thing to test, although I think this one will break the bank, is what happens if my minimum value is larger than the maximum value. And you see it breaks. So I won't go into fixing that. Obviously there would be ways to make it more robust. But it works as far as we're concerned here. So once you have this, so we have a minimum maximum number generator, it is useful to encapsulate it. Okay, so in encapsulating it, what I'm doing is taking all the elements that I don't need to see, the inner workings of a patch, and I'm excluding the elements that I do want to see. So I want to be able to trigger this manually or automatically. I want to be able to change minimum and maximum, so these are not selected. And I want to have the output as well, so you see this output object here is not selected. And then Command-Shift-E, or from the menu above, you can encapsulate this, and I will call this my min-max random. Okay, so that's a neat little way to go forward, because from now on, if I want to randomize something using min and max parameters, I just have it done. Okay, so that on the side. Let's now look at center and deviation. So what I'll do then is I'll duplicate this, because most of things are reusable. Center deviation will be the new set of parameters. And then obviously I'll have to change something about the insides of this patch. Before I do that, I can also rename it nice and neat. Center dev random. Okay, so how is this different? So again, let's start from an example of set numbers. So first of all, let's imagine I want to randomize a round value 5, and I want the deviation to be 2. So the question is, based on that, what will be my minimum and maximum? So actually, thinking about that, maybe the easiest way is to actually expand this one, because we now already have a min-max, and then we're just gonna do the math for center and deviation. I mean, in terms of center and deviation, what you have is two ways of thinking about it. You can think the deviation to be, if I say 2, so 2 numbers above, 2 numbers below. Or you can think of it as being 2 in terms of 1 above and 1 below. I think I'll opt for the first one. Okay, so let's imagine this. So if I have 5 and deviation 2, okay, then my minimum value will be 5 minus 2. And again, what I'll do is a bang for triggering the calculation when the left-hand side changes. Okay, let's verify that. 2, 3, whatever, 6, 3. Okay, if I have 6, so is this right? So this means that I have 5, 4, and 3 as the values below, which is fine. Those are 3 values. And then you're guessing it already. if I add these two values, and again take care of triggering the calculation when the right hand side changes, then let's go back to 5 and 2, 5 and 2, we get 7. Okay, and that's actually already done with, because we've already made sure that these are inclusive, both min and maximum value. So what I expect then is, if I connect these up, obviously I have to change these values because they don't update automatically. So let's do 6 and 2. So I expect values from 4 to 8 inclusive, and that's what's going on. Okay, so actually I'm pretty much done here, and the neat thing is that I can encapsulate an encapsulation. So I can just say hello. Well, actually let's call this one back min-max random, because that's what it is. Min-max random. Okay, and then I can encapsulate this one, and this now becomes my center dev random. All nice and neat. And then I can test it. Let's say I want center to be, let's try negative stuff as a matter of challenge. 8 and deviation, let's have only 1 up and 1 down. So I expect -7 and -9 to be in there, and both of them are in there. So the question is, why is this useful? Well, it is very useful because you can change your main parameter value without changing the amount of randomness. So see, no matter which value I choose here, I will always be getting 1 up and 1 down at random. So you can imagine easily me just connecting, for example, a slider to this one. And what I get is a funky slider, if I may use that as a term. So my slider is there, but it's actually always going around that value. Right, so it's a generative slider, you can call it. I can use another slider to control the amount of randomness. And then these two work in tandem nicely. Okay, so that's that. Basic min and max and center deviation type parameter control. And then next thing to look at is min-max control with a pace. Okay, so pace is the word I use to say something about the way in which the random values follow each other in sequence. And that is something to do with the maximum step size. Okay, so in max MSP we actually have a object that allows us to do this, which is called Crunk. It's just like metronome, sorry, just like random, except it has yet another inlet, and this one is the step size. So actually this is a fairly straightforward thing. I just added another inlet, send that to the second parameter, third inlet of the Crunk. And if I close that, I suddenly have another inlet here. So I can call this min-max base random. And let's keep it neat and briefly look at how this now differs from the basic random. So sliders seem to be a good way of basically seeing what's going on. So let's see how these two differ. So in this case I'll pick both to go full range. 0 to 128 is the default range of such a slider. So this is 0, 128 Turn this one on as well. And then you see that this one is kind of random, but it's really slow. So it depends on the pace. If the pace is fairly low compared to the range, it kind of keeps to the same range. I mean, eventually it will go to the maximum values. Question is how long we have to wait for that. But if I increase the pace, it'll just start jumping around. And the funny thing is, if I really increase it way above the range here, what I get is a lot of maximum values because they're being capped at 128. So it's a nice little way of controlling your randomness. Another way of calling this is a random walk or Brownian motion. Won't go into the theory of that now. Okay, and then the next one up would be to control the distribution. So all of these had equal distribution, meaning that every number is equally likely to occur, this thing we started with. And even this one has a uniform distribution, only it is likely to take more time to get to all the values if the pace is low. But theoretically all the values overall will have the same likelihood of occurrence. Now if you want to create a different distribution in MaxMSP, you use itable, and it actually works as a random generator already. So all you need to do is set some likelihood and bang this table. To make this slightly more transparent, I'll just pick 5 values. Okay, so what this means now is that I can set the likelihood of values 0 through 4. In this case I will get only number 1, and in this case I will get number 3 occasionally, but mostly number 1. So this is a good moment to actually test our histogram as well. So let's do that again. I have a histo, and then I have another itable, or actually in this case we can reuse this one because it's already size 5, although if I do trigger it very frequently, I really want more vertical resolution. Okay, both connect here, and then we should be able to get the distribution tested. So let's see, do it fairly quickly, 100 per second. Oops, and there they go. Cool. I think I'll have to finally, everything you skip in life comes back at you. Clear, that did work. I have to clear both. Because I just want to test different distributions as well. Let's go a bit slower, that ran up quite quickly. So let's do a distribution of few zeros, few threes, and a lot of fours. There we go. And that's what happens. Okay, so those are these basic randomization strategies. So this is my distribution. I will remove the testing so I can kind of have these in a nice little collection. I will type up here distribution. So before I go on to randomizing stuff, or actually just showing you the control of stuff, I'll just go into one more thing, which is probably the most complex one, which is a Markov chain. So a Markov chain is a way of setting the likelihood of random values following each other. You can look at the help file. Here it's called a weighted transition table, which is an accurate term. And the way it works is that you set the likelihood of each transition by sending a separate message for each of these likelihoods. So the way it works is that in this case we are saying that the likelihood of going from 1 to 2 is 1, from 2 to 1 is 1, and so on. And then obviously you will have a set of possible destinations from value 1 and a set of likelihoods. And you don't have to add up to 100%, so they will be weighted in the end. So let's try it out. So let's come up with a sequence or a set of likelihoods. Let's say from 0, I will go to 1 with likelihood 20, just so you see that the actual value here is not an absolute, it's a relative value. So it will be relative to all the other occurrences. And then to go from 0 to 2, I will have also 20 chance, and then to go from 0 to 0, I will have 120 chance. So much more. And then what I'll do is I'll just say, to keep it simple, from 1 back to 0, the chance is 20, and from 2 back to 0, the chance is 20. So if I have all these values, I have to send them all separately to the prob object, which stores them. And then what I have to do is send the initial value and and then trigger each next value as well. And let's see if that works. So I start at 1, next value is 0, next value is 2, but the next value is 0 again. Next one, 0. Okay, so that's likely. So I'm very likely to say it's 0 in this case, and then every time I do something else, I'm really likely to go back to 0. Okay, right. So that's a Markov chain. That's a weighted transition table, fairly powerful. So let's see it work. So what I'll do, I think the easiest way to see this one works, and I'm going to go into briefly showing you certain targets of randomizing stuff. And the first one will be the sample selection. So to do that, I will use something you might have seen in the previous video. It's my play 4 encapsulation. And well, I think I can just use this straight off the bat. Let's just instantiate these for security. Typically when you copy paste stuff, you instantiate a whole new object, so it doesn't carry with it what has been input as data. So we can probably verify this. It seems like it's spitting out numbers, but we should be able to verify it by listening to this. Now one thing, I'm using zeros there, and there's no zeros available here, so I'm going to add 1. So what I expect here is that this sample will play very frequently, and every time this sample plays, immediately after it goes back to the first sample, and anytime the second sample plays, it goes immediately back to the first sample. Okay, so let's have that happen automatically at a speed that we can verify. And here we go. Okay, so that's working, and you can create a set of transitions that end up without resolution. So if I send the value to number 3 and I have no likelihood of 3 going anywhere, then the probability gets stuck. But I won't go into that now. We're just exercising the right thing to do, which is typically to have a conclusive table such that there is no way of breaking it. Cool. So that's sample selection, sample choice. Just to look at all the ways of randomizing stuff in this context, well, it makes sense to create a distribution table. So let's try that as well. Here we go. So instead of the probability, we're going to use a distribution table. Again, let's use a +1, start from 0. Obviously this one has 5, but I won't bother resizing it. Let's just hear it happen. Oh, that's a bit fast there. 300 should be better. Okay, so I can say, well, I want the first sample to play only. The rest are unlikely to play. I want the third sample, second sample, fourth sample. And then obviously the interest lies in making sure that you have something frequently and something less frequent. Actually, this one sounds a bit like an open hat. And have these two equal likelihood, and then this one occasionally. How about this one? Okay, so that's controlling the distribution, the likelihood of different samples playing. So fairly important is to understand that these are rather different in the way that a Markov chain will change the sequence of things. So it is in this case certain that these samples 1 and 2 will happen only once and will never come twice in sequence. Whereas with the distribution there is no specification of sequence. So with the Markov chain you do influence the likelihood because you have a likelihood of transitions, and thereby you influence the overall likelihood as well. But with distribution it's slightly different in that the sequence is not specified at all. So even if I have something very likely and something unlikely, it could be that the unlikely thing happens 3 times in a row. Okay, right, so those are, let's just make this neat, call this Markov chain. So we're looking at 5 different ways of randomizing stuff and different targets. So the first target is indeed the sample selection. And for the sample selection, what you can say is that changing the range in different ways doesn't really make sense because the range here is quite finite. Obviously you can say, well, I want to randomize only the first 3 samples. But it doesn't really make a huge difference because you might as well avoid the 4th one. So we won't look into randomizing the range there. Few more things that I want to look at here is randomizing the triggering interval. Okay, so in that sense, let's start with minimum maximum. That should be quite straightforward. So here my triggering interval has everything to do with the metronome time interval. And in this case, I'm just going to use a single sample. So how do I do this? Well, here is my min-max randomizer, and now it's going to have another trigger. So what am I doing? I'm asking for a new value for each next occurrence. So every time the metro bangs, I need a new value here. And then I can specify the range. So let's say I want it between 300 and 600 milliseconds. So that spits out a new value each time, and then obviously the destination, the target for this value is the metro itself. Okay, so that's my minimum maximum randomization. Now in this case you already see that my center deviation randomization will produce a different effect in terms of user experience, because what happens there is, essentially have the same thing, it allows me to control the amount of jitter in tempo separately from the tempo itself. So it works as a kind of a randomized metronome. If I have a small deviation, it's almost straight, but not quite. And I can speed it up. That was slowing it down. Speed it up and have the same small amount of deviation, or I can indeed keep the center value and say, well, I just want it to be less precise. Okay, so in this instance it would be potentially useful to make the deviation a percentage of center, because what you have here is that if I go really fast, this amount of randomness is fair, but if I go really fast, then this is perceptually much more variation than if I go slow. But I won't go into that. Let's look at the other things. Distribution, or actually first the pace. Let's look at the pace. What happens if I randomize timing with the pace, with a given pace or similar patch. So every time I bang, I pick a new value. I don't need to see these things. So in this case, what happens is I have the opportunity to make sure that the tempo drifts slowly. So I can have a large range for the tempo, but it drifts fairly slowly in that range. So after a while, it is slowing down. So it can be interesting, useful in different ways. Done with that. And then come the distribution randomization. So if I do this, what I'm actually looking at is a fixed set of values. Now for a metronome, obviously I'm going to bang this each time. The issue will be that these values will have to represent time, and the I table will allow me only to set the maximum range. So it will always include zeros coming out, which is potentially useless for triggering events, very fast rates. So what I can do here is I can actually try and do something musical. If I have only 4 different outcomes, oh sorry, that was the wrong one. So the size is 4, that's the horizontal. Let's have slightly more vertical resolution. So I have 4 outcomes, and I can specify the likelihood of these outcomes, but I want these to be musically valuable in terms of time intervals. So what I can do is I can multiply this by 120. So if I multiply this by 120, I will get 0 to stay 0 and 4 to become 480. So actually before doing it, I'm gonna add 1 because 0 is useless for a time interval. Add 120, and then I expect 120 from this outcome, and I expect actually now I expect 480. Previously I expected 360. So if I do this, then what I can say is I want a lot of fast notes, and then occasionally I want the double duration and occasionally quarter duration, or 4 times quadruple duration. And I can play with this, I can create something potentially musical. Maybe that's my fancy. Or I can create a situation where I have a lot of slower notes. If I do something like this, I can create a triplet fill. Many different things can be done. Okay, so distribution control can be quite exciting when you apply it to timing. And shall we try the Markov chain as well? Let's not try the Markov chain. Maybe just theoretically. what happens there is that you will get a sequence of time durations. The reason I don't really want to try it because it won't become much more musical. One thing to say about making this type of randomization more musical is that we typically have a very strong sense of metric significance when we hear rhythm. So typically we impose the meter onto what we hear, and our expectations are governed by this activity. So in order to make this more musical, what we would have to do is create a system whereby certain steps in the sequence are more likely than others, meaning that we would have a strong sense of meter. Shall we try that? Let's try that. So with this one, I'm really getting distracted here. Shall we truly try this one? Nah, this is going for too long. Let's see your exercise. Try and do it. Let me know if you're stuck and I'll help you. Let's just try to wrap things up now. So we've looked at controlling tempo, and then two more things we will look at, and I'll really wrap it up now, is just randomizing the amplitude of playback. Now for that I've prepared this piano note here because I have access to the actual signal. So how do I make it so that every time this piano note is played, it plays at a different velocity, a different amplitude? So typically, again, I will have an automatic re-triggering mechanism which plays the piano note. Unfortunately it clicks a bit. It has to do with it abruptly restarting playback. It's a lovely piano note. Let's not be that rude to it. It still clicks a bit, but that's fine. And then I wanted to play at different velocities. So in this case, I actually already have a gain stage here, a multiplier, because it was a fairly soft piano note. And you see I've pushed the amplitude up to tenfold. So what I would like to have from this system then is each time a piano note is triggered, I get a different velocity. Now I could go between 0 and 10, in all honesty. That could work. Straight in there. So each one is of different velocity. Okay. Including the 0. So now it's useful to have a separate minimum control, because I can make sure that the 0 doesn't happen. Probably push it a bit more as well. Okay. And that's that. So I'll leave you to imagine how this would work out if I have it center deviation in terms of user experience. So these are essentially the same mechanism, just a different set of user parameters. And I'll leave you to imagine how it will drift up and down in amplitude, how you can make it so that certain velocities occur more frequently, and how you can make it so that there is a chain of things. By the way, the chain of things, Markov chain, the kind of the sequence control, is very interesting when you control the pitch. Right, so for velocity it might not be as musical, but for pitch it's quite nice, and actually even for harmonic progression. But we'll go into that another time. And then my last thing would be to show you other playback parameters, randomization of those. So in this case, let's leave the amplitude alone and just change the playback rate. Okay, so with play it is so that you can you need to specify the destination and duration as well if you want to change the pitch, right? So it's kind of going from 0 to the end of the buffer in a linear fashion. So if you have 1,000, 1,000, then it's gonna go at original speed. But if you take 2 seconds to go 1 second in the buffer, you will play at half speed. Okay, so that's what we need to figure out. So in this case, we need a start message. This is a fairly long sample. Now we're gonna start at 0. Let's do 4 seconds. Okay, let's verify it plays back original speed if I send it this message. It does. Okay, so if I want it to play at double pitch, I'll have to climb up twice in half the time. Okay, and then I want to randomize this. So in this case, in order to produce that effect, I do a $1 into my message, and then any number coming in here will be replaced for the $1. So if I have 3,000 coming in, that was the message created, and that's the tone played. So fairly straightforward. From here, I trigger my randomizer, and then I will send that value to become the duration, and then, well, 2,000 was twice the pitch. Half pitch would be 8,000. Let's get that going. Excellent, very moody and spooky. Maybe it's a good thing to finish this tutorial with. Thank you for your attention.